Hello guys, my name is Ronaldo. Welcome to the summer school. Unfortunately, I couldn't go to Cape Town, but I will try to explain a little bit about the Northeast Brazil marine ecosystem. How do you know TRIATLAS project? We will study some ecosystems in South Atlantic, and the Northeast Brazil marine ecosystem is one of them. In this presentation, I will talk about me and the lab. I will make a short contextualization of Brazilian fishery. I will show you some ecological models already applied on Brazilian Northeast ecosystems. I'm living in Natal City, and I'm working at the Federal University of Rio Grande do Norte. Rio Grande do Norte is a Brazilian state. And my lab working on freshwater and marine environment. In fact, we are doing some models, some ecosystem models, to simulate some human drivers like fishery, climate change, and pollution. In my lab, I have two postdoc positions, two PhD students, and two master degrees. All of them are working using ecosystem model approach. We are involving in some projects, and in this project, our participation is to make models, to collaborate, and to support fisheries, ecosystem-based fisheries management. You know this figure, and since in 90 years, the fishery didn't increase in the world, and the most productive countries in fisheries are China, Indonesia, United States, Russia, and Peru. Peru is a South American country, but just to remember you, Peru is located in Pacific coast, and this is a very productive environment because the upwelling, and Peru is here because this. Brazil is far from the first positions of this ranking, and but the fishing in Brazil is important because the employment. There are a lot of fishermen in Brazil or people involved in the fishery activities. But fortunately, in terms of GDP, fishery is not so important for us. Brazil has five regions, and the North one, the Northwest one, Southwest, and South region. And the Northeast one collaborate a lot with the fishery. More or less 30-35% is from the fishery, the landing is from Northwest region. This is the main species caught in Brazil: Sardinella, Paquiuro, Cynocium, in the mullets. This is the main, in general, the main species caught in Brazil. So, about the marine ecosystem, the Northeast Brazil has a coast with 3,000 kilometers, and in this coast there are many and wonderful landscapes. This fact attracts a lot of tourists, and there are some big cities. The majority of population lives close to the sea, and this is impact a lot of the pollution is big. It's hard in this on these ecosystems, and the ecosystem, the currents that influence this area is South Equatorial Sea Current and North Sea Current also. And here we have the Brazilian Sea Current. There are some islands here. The main one is Fernando de Noronha. Fernando de Noronha is here in this figure. and this is another place to dive in and attract a lot of tourists also. And the I don't know, the temperature is high, so it's good to surfing, to diving, to snorkeling, and but there are a high biodiversity of fish species, and we calculated that there are 200,000 people working on directly or indirectly on fishery activities. 30% of the Brazilian catch is from Northeast, and in Northeast catch maybe 97 or 98 is from small scale fisheries. The main species in Brazilian Northeast fisheries are the mullets, but just 10%. So the biodiversity of species, caught species, are very impressive. Então, so we have the mullets, bagres, sardinelas, centropomus, paquiurus, escomberomonos. And the shrimp and lobster have the highland values, and that are important here also, like the fishes. So we have a small scale fisheries, in coastal area. The target species there is a high diversity from the target species. The gears are a lot of them also. Many habitats, estuarine areas, coral reefs, beaches, and the fishermen have low income, low organization, literacy, and there is a lack of clear rules about fisheries. What I do, what the fisherman can do, nobody knows about, and there are a lack of land and monitoring. There are no management actions, and the state support is weak. What's the next? You can, in this situation, maybe the best solution is using an ecosystem modeling approach. The ecosystem modeling approach helps us to understand the ecological process and how we can impact the resources. Using the ecosystem model, you can simulate the management scenarios. And to complement the single species approach, single species are very important to understand the fish stocks dynamics. You can understand the role of natural drivers or human impacts on the resources, and the ecosystem model approach helps us to implement ecosystem-based fisheries management to sustain health ecosystems, to support their fisheries, and to sustain long-term socioeconomic benefits without compromising the ecosystems. And you can maybe use the co-management, using the fisheries technology, for example. I know you know what is a model. A model is a useful representative of reality, and it depends on your understanding of reality. You can be and you can do different models for different objectives. And for us here in TRIATLAS, we use the Ecopath, ecological pathways model, and the Ecopath is a mass balanced model, and you can simulate in temporal dynamics using the ecosystem module, and you can simulate spatial and temporal dynamics using the ecospace model. And if I have data about employment, about income, about wages of the fishermen, I can use the value chain model to understand the value chain of the fisheries. The Ecopath master equation is that one. For each compartment of my ecosystem model, I have one of this equation, and this is how the compartment grows, the production, and plus the biomass of the prey, and this is the consumption of the predator on prey, and this is the consumption rate, and this is the diet composition of this predator on this prey. This is the net immigration, the amount of prey that goes out from the ecosystem, and this is the catch, the yield of this prey. And this other mortality, no predation mortality for this prey. And this is the respiration, and this is unstimulated food of this prey. This is a Ecopath equation simplified. This is so for each compartment I have the biomass, the production biomass rate, the ecotrophic efficiency of prey, and this I have all the predators of this prey. So the biomass of the predator, the rate of consumption of this predator on this prey, and this export included the catch of the fishery from on display. This is a typical graph diagram of Ecopath, a snapshot of the ecosystem interaction and the exploitation, and you can quantify all these fluxes, flows, and all this biomass. In the ecosystem module, biomass varies over time. So we have the same equation from the Ecopath, but now varies over time. And the biomass varies over time. So we have a system of differential equation, and you can simulate for example, the catch of the species, and to calibrate properly the model. And after that, you can, after the calibration, simulate the model depends on my management scenarios. For example, here, increasing the fishing by 50%, by 10%, reducing the fishing, or testing or estimating the maximum sustainable yield from this species, from the species that I needed to understand. And for Northeast Brazilian region, we have some Ecopath models, and I will show you some of them based in this our project. It is a little bit okay. This is our area, and come on. Okay, and we have a Ecopath model from Atoll das Ocas, and for Pirangi estuary, and the Pacoti estuary, and the Sítio dos Novos reservoir. So you can try to take a look. Okay. This is some kind of monitoring. The data is quite new for us. We took this data last month, because of this project. For example, this is the data from Bahia Formosa, and you can see here this kind of the graph the Eurico developed is very nice to take a look to make some zooms in the species. Very interesting. And we have Ecopath and the value chain for Bahia Formosa also. And here I have we have the three Ecopath model for three estuarine areas. And okay, we have the four estuarine areas. One model we already have published, one bay, one beach, coral reefs, one, and the one for all the area for the northeast region. So we have two available approaches. I can use several and local small-scale fishes and to make one Ecopath model for each place and simulate the drivers, climate change, and fishing. And the other option is to make just one single Ecopath, Ecosyn, Ecospace model and using Ecospace to emphasize the difference among the areas and simulate the drivers. I will talk about a little bit about these two approaches. For example, for Formosa Bay, we published this paper and we use this Fisher's kinology to make this model, Ecopath model, and we use based on literature, scientific one. We did another Ecopath model and we compared the models, and the models are quite similar. And this is the Formosa Bay, the small-scale fisheries. And in Formosa Bay, we already published a value chain model. So we in a value chain we have the producers, or the fishermen here, and the distributor, the processors, the marketing, and the local consumer, the restaurants, and we understand the value chain here. For example, in average, the price of 1 ton of fish is $3,000, and when this fish goes to the local consumer, the price is double, is 6,000. And if the species, this fish, go to the tourist, so the price is so high because the tourists eat a fish using some particular species, so it's the price is high also. And we calculate the number of employments in each one of these levels of the value chain. Last month we got this time series of the catch. We didn't have it before to publish the papers, and now we understand a little bit more. We have 200 and 300 tons by year in this place, and the main species, this is tunas, lutijanus, scomberomenos, and we can understand the local problem, and you can simulate to make a Ecopath and the Ecosyn, maybe a Ecospace model here. And the other one is to do a Ecopath and the Ecosyn and the Ecospace. Paper is just Ecopath and the Ecosyn model. Here is calibrated for some species of this model, and uh, you can rebuild this Ecopath using a new and recent data set. Recalibrate the ecosystem using a reconstructed land time series to build the ecospace considering different land parts and the habitats, and to simulate the models of fishing and the climate change drivers. In this subject about the climate change drivers, I would like to show you the Atoll Rocas model. This paper is in preparation, and we use the IPCC scenarios, change the water temperature, and using the ecosyn, we noted that the total fish biomass decreased a lot using the most severe scenario of the carbon emissions. So the biomass of total fish is decreasing a lot after 70 years. So you can repeat this procedure for the Northeast region. This is not this is our intention. Using ecosyn, and in the ecosyn you can use the optimum temperature level for each species. To support ecosystem-based fisheries management, we can calculate some ecosystem indicators. For example, trophic level based indicators, trophic level of catch. You can understand if the fisheries suffering a fishing down food web. You can calculate the L index. This is an index about the loss in secondary production. You can calculate the FIB index, the fishing balance index. We can calculate the proportion of predatory fish, the pelagic to demersal fish biomass rate, or piscivorous to zooplanktivorous fishes biomass rate. So maybe to calculate sometimes if you don't have a proper model, you can calculate these ecosystem indicators to understand the temporal dynamics change uh, in your fishery. Just to conclude, so Northeast Brazilian fishery is a small-scale fishery. There is a high diversity of target species, many high diversity, many gears in the habitats. This is a lack of monitoring. We are took the data and join the plusing, and the fishermen are very collaborative here. So it's good to talking. We talk a lot of them. We learning a lot. Listen them. Local co-management is useful, and for us is compulsory. We need to do this. And for us, a unique model, a X-space model, is necessary to define general laws, but some decisions need to be local to define effective management actions. I don't know if it's useful, but I will suggest some exercise to estimate ecosystem indicators, and I will send for Noel and Mathieu the time series from Formosa Bay Catch. You can use it to calculate this suggested exercise to this exercise. In fact, this time series is short, but to make an exercise, it's good. It's easier. Thank you very much. Sorry for my absence. I really try to go to Cape Town, but I had a lot of bureaucratic problems, and it's difficult for us. Okay,